take 802. Oh my gosh. I don't know why, but this one has taken me a few to do. At least the dog is gone. She's not licking anymore. But here we go. We have Avogadro's number of pennies. We spread that out. We give that to everybody in the U.S. So 290 million people who live in the U.S. And we ask the question, how many dollars would each person receive? Okay, we're going to give them pennies. They have to somehow take those pennies to the bank, and they have to figure out how many dollars they have. All right. So we have to figure out an Avogadro's number of pennies. So we have 6.02 times 10 to the 23rd pennies. We give that to 290 million people. Okay. Before we go on, this has either 2 or 3 sig figs. It's a little ambiguous. That 0, you don't really know if that's a placeholder or if it's something that it just happens to be a 0 and we measured it. So 2 or 3 sig figs. It could be either, and I would be fine with either one, okay? If we figured this out right now, we would have pennies per people. Okay, pennies per person. And so we need to go, there's 100 pennies in $1. This will give us, pennies go away, this will give us dollars per person, which is what it's asking for. So if we do that, you get 2.07 times 10 to the 13th dollars per person. The point is, we're giving out pennies, we're giving out a huge number of them, but still we're giving out pennies. And look how rich, it's trying to show you the magnitude of Avogadro's number. It's huge, okay? If you did it as 2 sig figs, it'd be 2.1 times 10 to the 13th. You would round it up, so it'd be 2.1. Either one would be okay. All right, now we're going to move into some mole island kind of problems, okay? Look for the question, how many moles are in 15.3 milligrams? This is where you start. This is where you end. Okay, so we're going to go from milligrams to grams to moles. We do that because milligrams to grams is just a metric conversion, and then grams to moles, we need molecular weight for that. Okay. 15.3, 3 sig figs. Answer has 3 sig figs. So we have 15.3 milligrams. Like we did on problem 9, molar mass just needs to become automatic. It's just something you do it quickly. So it's 162.3 grams per mole. I'm not going to show you how we did that. So we're going milligrams to grams. Why do we do that? Because this is grams per mole. That's our bridge from grams to mole. So we have to be in grams. So there are 1,000 milligrams in a gram. 162.3 grams in a mole. It said how many moles, so we're done. All right. Equals 9.43 times 10 to the minus 5 moles. 3 sig fig. So that's why we have 3 numbers there. All right. Number 12. We're talking about capsaicin. Once again, some other weird thing with formulas. You got to get quick at these molecular weights. Just put in your calculator. 18 times 12.01 plus 27 times 1.008 plus 1 times 14.01, I think, plus 3 times 16. All right. So you just put that in. We get a molecular weight, 305.4 grams per mole. We're going to need that. So we want to know how many atoms of carbon are in this many grams of capsaicin. Okay, so we start here. We end here. You look for the how. How many? That's most of the time that's where you're looking for your start and your end point. 3 sig figs. So our answer is going to have 3. So we're going to start with 0.662 grams of capsaicin. We'll call it cap. Okay. We're already in grams, so we can just get that to moles right away. 305.4 grams of cap and 1 mole of cap. Now we're in moles of capsaicin. We want atoms of carbon. So let's go to moles of carbon. So for every 1 mole of cap, and it may be 1, but in this case it's not. It's 18 moles of carbon. So now we're in moles of carbon. Okay. So now we can go to atoms of carbon. For anything, 1 mole of something, so in this case it's carbon, there's 6.02 times 10 to the 23rd atoms or molecules. If you're not doing carbon, if you're doing capsaicin, you'd say molecules, atoms of carbon. Okay? 2.35 times 10 to the 22nd atoms of carbon. That is my answer for number 12. 3 sig figs, so that's why 3. All right, last one in this set. We have this compound, chloral hydrate, used for Mickey fins. There's a lot of talk here. There's a lot of things. Suppose you have 1 gram of chloral hydrate. So this is going to ask us a lot of things. We're going to have to do a lot here. How many atoms of chlorine? How many grams of oxygen? How many moles of carbon? Okay, so it's 3 separate problems. Let's do the first one. Atoms of chlorine. So we're going from 1 gram. We're always going to start with 1.00 grams. We have 3 sig figs, so that's what our answers are going to have. So let's call it chlorohydrate. Let's just go, that's good enough. Okay. Now, we get to moles. It's 165.4. We're in moles of that stuff. Okay, so now we want atoms of chlorine. Moles of CHL times, okay, 1 mole of this stuff, 1 mole of CHL, there's 3 moles of chlorine, and then for every mole of chlorine, there's 6.02 times 10 to the 23rd atoms. Okay, 1.09 times 10 to the 22nd atoms of chlorine. 3 sig figs. We're going to do these quick. How many grams of oxygen do you have? Well, so we're going to do the same thing. We're going to go to moles. This time we're going to go to moles of oxygen. So 1.00 grams of CHL. 165.4 grams CHL per mole of CHL. So in 1 mole chlorohydrate, we have 2 moles. We have 2 moles of O. And then we're going to grams of O, right? So for 1 mole of O, there's 16.00 grams of O. All right, so 0.193 grams of O. And then the last one, moles of carbon. So we're going to do, again, the same thing. Instead of going to oxygen, we'll go to carbon, and we can stop there because we'll be in moles. So C, 1.00 grams of CHL times 165. And we could have we could have, I don't know what I was going to say. We could have figured out moles of CHL and then just started all of our problems there because we're doing this 1 divided by 165.4 for every problem. 1 mole of chlorohydrate, there's 2 moles of carbon. So there's 2 moles of C. Since we're in moles of C, we are done. 0.0121 moles of C. That is that problem. All finished. Yay!